Hi and welcome back to my channel. This week's problem is trying to find the shaded area. We have got a quarter of a circle here, OAB, and we have got a square which one corner intersects exactly with the center of the quarter circle and the other top right corner touches the circumference of the circle there. Now, as you can see, there's an angle of 27 degrees between the bottom left side of that square and the bottom side of the perimeter of the quarter circle. The radius of the quarter circle is 10 centimeters. Can you solve this problem and work out the shaded area? If you can, let me know down in the comments below what your solution was, because I'm going to go through my solution in 3, 2, 1. Okay, so the first thing that I want to do with this is I want to draw on a radii, okay, and the key one is going from the center of the quarter circle, O, to the point that that square touches the circumference. Now I know that's going to be 10 because it's a radius, so I'm going to add that on later. For now I want to think about the angles, and I can work out this angle here because the diagonal will make a 45-degree angle within the square, and so that angle has to be 18 degrees. Now I know the other angle here must be 45 degrees as well, but I can work out the full angle of that sector by doing 90, because there's 90 degrees in a quarter circle, subtract the 18. That will give an answer of 72 degrees. Now from there, I can work out the area of the quarter circle, so the area of all of this. Now the area of a sector is theta over 360 times by pi r squared, where theta is your angle. So in this case, we're going to use 72. And the area of the sector can be worked out by doing 72 divided by 360 times by pi times by 10, because it's the radius, squared. Now, when you put that into your calculator, when you solve that, when you work it out, what we get is 20 pi, which is quite nice. Now from there, you've probably realised all I need to do is take away half the area of the square, or the area of a triangle, area of the triangle away from the area of that sector. A problem I've got is actually I don't know at the minute what the side length of that square is. So I'm going to call the side length x. Now I know within a square I can use Pythagoras, so I'm going to use Pythagoras here, and I'm going to do x squared add x squared is equal to 10 squared, the hypotenuse squared. Now that gives x squared add x squared is 100, which simplifies to 2x squared is 100, which then gives x squared is 50, and finally x is 5 root 2. Okay, now from there, what I'm going to do is I'm going to put that onto my diagram. I'm then going to work out the area of half of that square, or the area of the triangle. So I'm going to do a half times 5 root 2 times 5 root 2. And that gives an answer of 25. Then to get the area of the shaded region, I'm going to do 20 pi, the area of the sector, subtract the area of the triangle to give me a shaded area of 20 pi, subtract 25 centimeters squared. If you were able to solve this problem as well and you use a different method, let me know down in the comments below so that we can share with everybody else who's watching. But all that's left to say from me is thank you very much for watching. It's been a quick video this week. If you enjoyed it, make sure to drop a like on the video, and if you're not already, please consider subscribing to the channel. There should be another video just up here that you can click on to watch next. Thank you very much, and I'll see you next Monday at 5 PM for another problem solving video. Bye bye.